Hello, my name is Andrew Padilla. I'm the founder of Datasekia, a data engineering solutions company. Today, I'd like to talk about a phenomenon I've observed in my career as both a software and data professional. My topic today is about the growing disparity between the evolution of digital logic and data. I'd like to take a ground up approach to examining these two most elemental building blocks that compose our digital knowledge infrastructure, and from that apply systemic perspective to address this apparent disparity. Starting with a baseline, let's examine the characteristics of systems quickly. What is a system? A system is a set of things working together as part of an overall mechanism. Components in a system are often complementary, interconnected, and interdependent. This is true at every level and across domains, whether it's biological, economic, social, and of course, digital. Components are often not useful by themselves. They are often useful in the context of a system. So let's examine the behavior and characteristics of digital systems in the context of logic and data. First, I'd like to establish the premise that logic and the data it operates on are intrinsically intertwined. They are two parts to an overall mechanism. One invariably gives rise to the other. The application and data lifecycle is a continuous feedback loop that only creates more apps and more data. Unfortunately, the growth of data is far outpacing most organizations' ability to get value from it. This cyclical nature between logic and data requires that in order for the system to provide value as a whole, there's a real need to achieve balance between the two. And yet, the state of development of our digital knowledge infrastructure has largely favored the advancement of the logic side of the equation. We have access to a sea of third party libraries, frameworks, and components to build our applications, largely assembled from GitHub hosted open source projects. We have cloud based platforms as a service offerings that can be leveraged to deploy and scale our applications with the click of a button. With DevOps processes in place, we can reduce the time it takes to deploy an application changes. And lastly, with microservices, we can bundle discrete runtime components of our application logic and orchestrate them in any number of ways to be used by current and future applications. The level of portability and granularity for application logic is unprecedented. Notably, over the last 20 years, we have developed a potent combination of open source culture, technology, and processes to evolve application logic at unprecedented speed, and at the same time make them more visible, accessible, and usable than ever before. But what about the data that it both consumes and produces? What equivalent machinery do we have for the development of data? How do we make data more visible, accessible, and usable? I believe these questions are valid as symptoms of this disparity are only growing. Not surprisingly, there are ever increasing number of data sources in organizations today. I would expect this to explode with the proliferation of IoT. Likewise, interoperability issues between systems are growing in lockstep. As a result, it is estimated that data professionals spend upwards of 80% of their time looking for and/or curating data. This mounting frustration has turned the industry's attention to data governance initiatives and related technologies such as data catalogs. It's not difficult to find countless resources on how to effectively manage big data, yet very few organizations have claimed success since this term was first coined in 2005. So, what is it about application logic that allows us to create, share, and modify it in any number of ways? Simply put, it's because it's highly composable. Just like DNA is composed of only four different nucleotides that are arranged in different ways to create all living things, so too can source code's building blocks be arranged in a way that are only limited by one's imagination. Logic and data share corresponding building blocks at every level of composition, and these building blocks are highly interconnected. So the question then becomes, Why can't we apply a similar approach to the development of data that provides us the visibility, accessibility, and usability, that we enjoy in software today? Application logic is built around programming languages whose useful composition is only limited by the software developer who creates it. Imagine what our digital knowledge landscape would look like with the development of these two integral components at parity with one another. What equivalent language do we have for data that can serve as a basis for the development of it? That language for data is metadata. Simply put, metadata is data about other data or data that describes data. Metadata is a foundational yet often overlooked component in the evolution of computer systems today. And I think it will arguably play a more prominent role in the systems of tomorrow. Metadata can describe how data is labeled or named, how it is composed or structured, or provide some other contextual information about the data. Metadata enables application logic to recognize, if you will, the data that it is processing and therefore how to process it. Metadata addresses the who, the what, when, why, where of data that it refers to. It allows us to model the world we live in and through that provide value to our everyday experiences. Metadata is also instrumental in enabling how computers communicate with one another. Without the notion of metadata, computers are effectively reduced to their most basic operations as calculators. As such, metadata enables higher level operations to be performed, such as web browsing, getting directions to a restaurant, booking a vacation, online shopping, or many of the other common tasks we simply take for granted and enjoy today. The focus on artificial intelligence today implicitly requires an environment which machines can learn. For that, you need data, lots of data. Metadata will be instrumental in finding that data and using it effectively. In fact, a similar attention on the role of metadata was espoused in 2001 by Tim Berners-Lee, the father of the World Wide Web. He called it the semantic web. While this idea did not take hold in the frenzy to evolve application infrastructure that we know today, the pain points are increasingly evident for the spirit of this idea to take hold moving forward. So what can we learn from achievements of open source and apply it to the notion of open metadata development? There's no question that the open source movement has forever changed the landscape of how software development is performed. In his seminal white paper titled The Cathedral and the Bazaar that captured the movement, open source evangelist Eric Raymond described two largely different models of software development. In the Cathedral model, source code is developed closely by a few select individuals. In the Bazaar model, software development is performed out in the open with no barriers to participation. Prior to the advent of the open source movement, most developers devise common building blocks in isolation or purchase proprietary commercial equivalents as needed. Today, open source software serves as a strong foundational rock for many of the software projects that it's based on, and barrier-free collaborative model. Open source is indeed powerful, primarily because of the liberty afforded to the user. Software developers are at liberty to use, change, contribute as they wish. Software libraries and applications are largely visible, accessible, and usable to anyone. However, liberty alone was not the exclusive driver to the present-day ubiquity of open source. Every movement needs a delivery vehicle to catalyze those principles into action. The open source movement found that through one of its own creations, Git. Git is a decentralized version control system that was conceived by Linus Torvalds, who also happens to be the author of the project that arguably sparked the open source movement itself, Linux. Git allows developers worldwide to collaborate on open source projects as well as closed projects. Git allows developers to work locally and manage their own changes, then share those changes with others in a common repository. Git allows for co-evolution of those changes in a scalable manner, all while the lineage of those changes are tracked. Its decentralized nature allows software developers to manage their own version of the truth and later merge them to a commonly shared version. The decentralized workflow for source code version control has exploded how source code projects are discovered, developed, evolved, and delivered on a global scale. Through Git, we have no shortage of available software. However, we don't have an equivalent vehicle on the same scale to drive the visibility, usability, accessibility for metadata and engender a global community. Looking at the evolution of source code management, we see that source code version control systems evolved from standalone offerings to be used in isolation, as shown in red, to centralized servers that allow developers to collaborate within an organization, as shown in yellow. Finally, as shown in green, with Git and its derivative offerings, source code collaboration exploded to a global scale in a decentralized fashion. Metadata management historically has been a feature rather than a solution. For example, SQL databases have always provided system tables that describe SQL objects defined in a database. Hadoop leverages Apache Atlas to manage metadata in its clusters. Other offerings may provide metadata stores that capture the context of an application workflow and use that to provide some form of enhanced user experience. Over the past 10 years, there's been an increase in data catalog offerings who are attempting to provide centralized repositories for all metadata in an enterprise. This progression is very reminiscent of evolution of version control systems for source code, as we move from isolated standalone metadata stores to centralized ones built for the enterprise. I believe, however, that there is an unmet need for a decentralized community for metadata curation whose scope is broader than the enterprise concerns and impact more profound. Like its source code counterpart, there are real efficacies to be gained from having unfettered curation and sharing of metadata on a global scale. As evidenced in the evolution of source code management, sharing within an organization has only limited value. A centralized metadata management strategy does not adequately harness the collective global intelligence and resources required to address an increasingly complex digital landscape, nor does it scale. By leveraging the equally composable nature of metadata to bring forth the notion of metadata development, self-organizing communities would be free to curate, share, and orchestrate content from any number of perspectives. I see the pervasive use of global metadata version control repositories as a necessity. Like GitHub, its value becomes obvious over time as users start to question their own tribal beliefs regarding data in favor of the collective wisdom of the community that asks for nothing in return. From here, a sense of community is born and becomes the norm. Only then will development of data achieve parity with its logic counterparts by attaining the previously reiterated outcomes of visibility, accessibility, and usability, in addition to the repeatability and reproducibility characteristics that are sorely needed in systems to help address the current pain points in our development and usage of data today. I hope you enjoyed this, and if you have any questions, feel free to contact me at datasecchia@gmail.com. My website is www.datasecchia.com. I can also be reached on LinkedIn as well. Thank you.